Hey guys, welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about the different kind of layer parameters we have in neural networks, and we're going to talk about the different kind of trainable parameters and how we train the different kind of parameters in a neural network when it's training. But first of all, remember to join the Discord server we have here on this channel, where we have a small community where we can discuss the different kind of things within deep learning and AI and computer vision. So if you have some problem with some of your projects or applications, feel free to join the Discord server and ask your questions or come with some feedback to other guys. So the link is in the description here, so make sure to join the channel and check that out. First of all, here we're going to talk about the overall stuff about the layer parameters in neural networks. So first of all, we've already talked about we have some different kind of weights for each of the connections in our neural network. So we both have weights and we also have biases. So I have mentioned that we have biases in a neural network before, but in this video here we're going to cover and go more into details of what biases are and what we can use them for in neural networks. So we have these different kind of layer parameters for each layer, and each neuron we have different kind of parameters that are learnable, and these parameters here are learned during training. So when we're training a neural network, we learn the best parameters inside of our neural network. So first of all, here we have an input layer here. So this is just an example of a really simple artificial neural network. So we have a value here for our input layer, and then we're talking about all of these connections here between the neurons and the layers in neural networks. They have a weight. And in this video here, we're going to cover that these connections here also has a bias. So we will combine the weight and bias here for each of these connections here, and this is actual value that gets passed to the activation function of the next neuron here. So first of all, here we're going to cover what is bias in neural network and what it is and what it can be used for. So ideally, the bias in the neural networks, it determines if a neuron is activated and how much it is activated at a certain time. And this increases the flexibility of our model, which is good during training because we have this more flexible parameter, and we both have the weight and the bias that we can actually train and tune on. So we have a bit more flexibility in our model and in our neural network. So the output here of a neuron here will be the activation function, which we pass the sum of the weights, which we already talked about in one of the previous videos. So we sum all of the weights here coming to a neuron here, for example, and then we also add the biases for each of the neurons. So actually, each neuron here has both a weight and a bias in the neural networks here. And then we pass these two parameters here where we sum the weights and the biases together, and then we pass that to our activation function. And depending on what type of activation function we have, then we can determine what the output should be and how much the neurons should be activated at a given time. So an example down here, we have an input value here for 2 neurons, which is just 1 for this simple example, and then we have a weight here which is a negative 0.5 and a weight down here which is just 0. So if we add all of these weights here together and multiply it by these input values here for these neurons, then we'll get a value here of negative 0.5 to the activation function. And depending on what type of activation function we will have, then we'll have an output which corresponds to some value. And in the case we're using the ReLU function, activation functions, which is very often used, then when we pass a negative value to a ReLU activation function, then the output of that activation function will just be 0. So that means that this neuron here won't be firing if we're just using the sum of weights here as the input to our activation function, and we're only working with the weights of these different kind of connections between the neurons. But if we're going to use biases in a neural network, we can actually make it dependent on the bias as well, if the neuron should be activated or not. So let's say we, for example, have a bias here for this neuron, then we can actually have a bias of 1 if we want this neuron here to be activated instead of not activated at some point. So if, for example, have a bias here of 1, then we actually add 1 to this negative 0.5 here, and then we'll actually get positive 0.5. And when we pass positive 0.5 to our regular activation function, then the output will also be 0.5, because it is only when we have negative values, those will just be 0, or else the positive values will just be the exact same positive value. So then by just using biases, we can actually convert a neuron that is not activated to a neuron that is activated, and we can actually control how much our neuron will be activated. And it also works the other way around. If we have a neuron that is firing and we don't want it to be foreign, then we can have a negative bias in that case. So this is just a simple example where we only have 2 connections and only one of them is actually like activated. So this is like how we can use biases together with the weights in our neural network, and it just increases the flexibility of the model, and it can be used for in the training process for making the neural network learn faster and also better. So this is the essential thing in biases, and we're going to cover more about this here as well, and how we can like calculate how many different kind of learnable or like trainable parameters we have in a neural network. So how can we find the number of these tunable or trainable parameters that we have talked about now? So if we're just talking about artificial neural networks here, then we have this simple example down here where we can actually like find the number of parameters that we can tune or train during training by taking the inputs of a layer and then multiplying that with the output, the number of neurons in the output layers, and then adding all of the biases. So if we're operating with biases, we often have like one bias for each of the connections, together with a weight. So in this case here, if we just take this simple example down here, we go through the first layer here, which is the input layer, and we will have 2 neurons in this input layer here. And in our first hidden layer here, we have 3 neurons, and because we have 3 connections here, we will also have 3 biases. So this means that we have 2 multiplied by 3, and then we add the 3 biases here that we get from these 3 connections into this neuron here. So that means that in this hidden layer here, we have 9 trainable parameters, and we can do the same thing here as well for our output layer, where we have 3 input neurons here, and we have 2 output neurons, and then because we only have 2 output neurons, we will have 2 biases here that we can add to our trainable parameters. So if we add these add these numbers up here, we get 8. So in this simple neural network here, we actually like have 17 trainable parameters that we can tune on and modify during our training process if we're going to train this neural network here. And over here to the right, I have a summary of the sequential model that we created in one of the previous tutorials in Keras, where we had these input layers here, where we had this vaccine trial where we wanted to predict if a patient had side effects or no side effects. So if you haven't checked that video out, make sure to go back and check that one out, where we created our own neural network. We created some random data that we trained it on, and then we went through the whole training process and actually like did predictions on new data that it hasn't seen before. So in that video, we went through all of it, and here we're just like talking about some of the different kind of things that is going on behind in the neural network training process. So first of all, here we have an input layer here of 2 neurons, and then we have a hidden layer of 24 neurons and 12 neurons, and then the activation layer has 2 neurons here. And then we can actually like see all of the parameters here that we have for each of the layers in a neural network if we call this model.summary in Keras, and I'm going to show you at the end of the video here as well how we can do it. And then we also get the total parameters and the total number of trainable parameters that we have in this neural network here, and we can use that information to see like the complexity of our neural network and how many actual like parameters that we're able to train during the training process of a neural network. So in this video here, we're also going to talk about weight initialization, because it's a really important thing, and also just to know what is going on when we're initializing our weights in a neural network. So the weight initialization is when we're initializing our weights in our neural network. So there's some different kind of method for it, and we have some different kind of weight initializers, but we have to initialize our weights to something when we just create a neural network, and then when we're training a neural network, it will actually like adjust those weights to get like the best result or like the best accuracy of our neural network. And again, we just use it to have this like initial standpoint where we can then tune our weights during training. And we can actually like use something called a seed if you want to replicate the result, because when we're using these layer weight initializers, we have some built-in in Keras, where we have this, for example, the random normal distribution class or a random uniform class. And actually like the default one in Keras is this glorious uniform class here, which is also the savior initializer. And I'm going to show you the documentation of like what these different kind of weight initializers are and how they're defined. But if we just take like a normal distribution here, for example, we have this normal distribution here of the data. And then when we're initializing our weights, we have a mean here of 0. So this will be the mean value here of the data. And then often we will have a standard deviation of 1 of the data here, when we're using this normal distribution to initialize our weights. And then we'll get like most of the values around 0 with some standard deviation, and often it is just 1. So I'm going to show you in the actual like documentation how some of these different kind of initializers is defined, and also like how they're tuned to get the best result. And if we, for example, have a uniform distribution here, it will just be like a random number. So we just have a uniform distribution, and we will just have like the graph will just look like something like this, instead of this normal distribution here, where we sample from a like a 0 mean here with some standard deviation, which is often 1. So we're going to also talk about like the parameters in convolutional neural networks, because they're a bit different but still kind of the same as in artificial neural networks, and we're going to cover more in other videos when we're going to cover the convolutional neural networks. But this is just like an introduction to, and so you can get like an understanding of like how complex convolutional neural networks are compared to artificial neural networks. So to actually like get the number of tunable or like trainable parameters in convolutional networks, we take the number of filters, because when we're operating with convolutional neural networks, we're operating with filters in the convolutional layers that we're actually like implying or convolving on our images that is passing through our neural network. And then we take the number of filters here and multiply that by the number of filters times the size of the filters in the like the hidden layers here, and then we add the biases as well as we did in the artificial neural networks. So for example, here we have an input image here, which just has like one dimension, so it could be a grayscale image. And then we have the first convolutional layer here, which has two filters, and the filter sizes are at 3 by 3. So in this case here, we will have 9 here for the size of the filters, and then in this layer here, we'll have 2 filters, so it will be 9 times 2, which is 18, and then we just multiply that by the number of filters here in the input layer, so that will be 1. So again, we just had 18, and then we also add the biases, which is just like the number like filters here that we have and biases in our neural network. So we will just add that to this number here that we calculated, and then we can do the same thing here for the second hidden layer. And then for our output layer, we actually like have to flatten our neural network first before we can actually like pass it to a dense layer, and then we can get an output if we, for example, do some classification problem. But we're going to cover like the flattened layer and how flatten is done on images to convert it to a dense layer in later videos, where we're going to cover convolutional neural networks. So this was just to like give you an introduction to like how we can also like specify or like calculate and find the number of tunable parameters in a convolutional neural network. And if we add all of these numbers up here together and do this math here from this formula, we'll actually like get a lot more tunable parameters for this simple convolutional neural networks to compare to the artificial neural networks that we just went over, which had 17 tunable parameters. So we're now jumping into the Keras API reference here, and I'm going to show you the different kind of weight initializers that are talked about in the slides and how some of them are like defined and implemented. So first of all, here we're going to the Keras API reference, and then we're talking about the different kind of parameters in the layers and how we can initialize the weights in the layers. So we'll go into this layers API here, and then we can actually like see that we get a lot of different kind of options here in the layers. But we have to go down here to the layer weight initializers in the documentation here, and then we can actually like read everything about like how we can initialize or like how the weights are initialized in Keras. And first of all, here we get a short introduction to like the uses of the initializers. So initializers define the way to set the initial random weights of the Keras layers and the neurons in the layers. And we can see like the keyword arguments used for passing initializers to layers depends on the layer. Usually it is simply layer like kernel initializer and bias initializer. So we can actually like both initialize the bias and the value for the neuron, or like for the weight, so the weight initializer. And then we can see like how we can use them. So we can just pass this kernel initializer here and then set it equal to the initializers and random normal, and then we will have like a random normal. It will have a standard like a mean value of 0, and then we can actually like specify the standard deviation here, which is the deviation from the mean. And then we can also see like how we can actually like apply here in the kernel initializer. So we can set it to random normal and bias initializer. So we initialize all the biases in our neural networks to 0 as a default. And then when our neural network is training, it will actually like adjust and modify these different kind of parameters here. So we just add more flexibility to our neural network during training when we have this kernel initializer, and also when we're using biases in our neural networks together with the weights. So if we go down here to the different kind of, over here to the right, we can see the different kind of implementations of the weightable initializers or weight initializers in Keras. So I talked about the standard one, or like the default one, is this colored uniform class here. So we can see that this colored uniform initializer here is also called the savior uniform initializer. And we can see that it draws sample from a uniform distribution within a negative limit to a positive limit, where the limit here is the square root of 6 divided by the fan in plus the fan out, which is the number of input units to our neural networks, and the number of output units, or like neurons from our neural network, which we can also read here, which is the fan in is the number of input units in the weight tensor, and fan out is the number of output units from that weight tensor. And then we can actually like use this calculation here, or this formula here, to calculate this limit, which will be this limit up here, which is where we will get a uniform distribution from that minus limit to a negative limit to the positive limit. And this formula here is just derived from experience, and it will yield a really good result by using this formula here, instead of just using, like, for example, a regular uniform distribution where we just have a random number. Like, for example, if we go up to this random uniform class here, then we can just see that initializer that generates tensor with a uniform distribution, and we just give it a minimum interval and a maximum interval, and then it will just return a random number from that, instead of the calculated interval that we had down here in this colored uniform. And we can also go into the normal class here if we want to use a normal distribution instead of using this uniform distribution where we just take a random number. Then we can use this colored normal distribution, where I showed you like this normal distribution in the slides. So first of all, we calculate the standard deviation here, which is the square root of 2 divided by fan in plus fan out. So this is just a way, and this is just like a found value, which is really good for using when we're using these weight initializers, and these are just like found by trial and error and stuff like that. So we're now jumping into Google Colab here, and I want to show you like how we can specify these different kind of weight initializers in Keras, and also like how we can do a summary of our model to see how many trainable and learnable parameters we have in a neural network, and also see like how we can get the initial weights from a neural network before we're training. So first of all here, as we've already seen in some of the previous tutorials or videos, we're first going to import all of these things here that we want to work with from Keras and TensorFlow. And then we can specify this initializer in this way here, for example, where we have an initializer that we set equal to TensorFlow, that's Keras, and the initializer from Keras. And then we choose this colored normal distribution here, and then we can actually like specify a seed. So we want to use the seed, or like we want to specify a number here if we want to replicate our like training process and our weight initialization again, and we want to replicate the same result, because if we don't specify a seed here, it will just like take a random seed every time, and we'll just get random results. So if we want to replicate, we need to specify the seed here. And then we're going to use this model here that we created in the previous videos, where we created this neural network here and trained it on some vaccine data. So I'm just going to show you like we can do it in this way here, and then we can specify the kernel initializer, or like the weight initializer, in this way here as well, instead of doing it like this. So then we can specify it to this colored uniform distribution here, which is actually like the default one, so we don't have to specify this. This will just be the default one if we don't specify anything else. And then in the second hidden layer here, we can actually like just use it like this kernel initializer and set it equal to this initializer that we specified up here. So if we run this model here and we create this model here, now we have actually like created a model, and we have initialized our weights in the first hidden layer with this colored uniform, and the second hidden layer we initialize the weight with this colored normal, where we have this specified seed. So if we go down here and do a summary of our model, we can now see like we get all of these different kind of layers where we have a number of neurons inside of it, and then we can actually like see how many parameters, or like how many trainable parameters we have for each layer in a neural network, layer for layer. And then at the end here, we can actually like see the total parameters we have in a neural network here that is trainable, and the number of like parameters that is learned during training of a neural network. So this will specify like how complex our neural network how complex our neural network is, and also give you like an understanding of like how many different kind of parameters is tuned during training. So if we just want to see like the weights that is initialized in our neural network, we can use this model.getWeights here. And if I run this self code here, we can actually like see all of the weights here for each neuron in our like each neuron and all of the connections in our neural network. And we can see here that we get some values here from with it like kind of like a standard, like a mean of 0, and then with some standard deviation. So we can see that that like the mean value is 0, and then we have a deviation in the negative range and the positive range, with some certain standard deviation of 1, for example. And then we can see that we get all of these initial weight values here between negative 0.5 and positive 0.5. And we get all of these weights here for all the layers in our neural networks, and we can see all of them. And the ones that we specified as seed, then those will be initialized to the same every time we run this block of code here, where if we don't specify any seed, it will just get some new random numbers. And this is the initial weights in a neural network. And then once we start training on neural network, all of these parameters here will get adjusted to get the best performance and accuracy of our neural network. So this is like how we can specify it in Keras, both with the weight initializer and also the bias initializer, and I showed you in the documentation how we can do it and also like how we can specify it. So we're going to use this here in later videos, where we're actually like going to do some more neural networks, where we're going to train them, and we're going to talk about more about the weights and trainable parameters and how many trainable parameters you need for specific and different applications and projects. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video, and also like this video here if you like the content and you want more in the future, because it really helps me and the YouTube channel out in a massive way. And if you're interested in more of the other tutorials I'm doing, I'm currently also doing a computer vision tutorial in C++ and OpenCV, and also an algorithm and data structure tutorial in C++. So if you're interested in one of those other tutorials, I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.